Today we'll discuss about heterocyclic chemistry part 9th. What is Kineline? Kineline is a heterocyclic aromatic organic compound with the chemical formula C9H7N. Kineline is a fused heterocyclic system consisting of a benzene ring fused with pyridine cycle. It can be also considered as the heterocyclic analogues of naphthalene. Systematic IUPAC name is 1-benzopyridine. Other name is 1-asa-naphthalene. Kineline is a colorless liquid with an unpleasant odor and boiling point is 237 degrees Celsius. It is miscible with water, ethanol and ether. It may be distilled by steam distillation. Structure of Kineline. All ring atoms in Kineline are sp2 hybridized. As in the case of pyridine, the nitrogen lone pair electrons reside in an sp2 orbital and are not involved in the formation of the delocalized pi molecular orbital. It shows aromatic properties because its pi orbital contains 10 electrons and satisfy the Huckel rule. Kineline is considered as a resonance hybrid of 3 canonical forms. It has the molecular formula C9H7N. It gives the electrophilic substitution reactions like benzene and forms salt with acids just like pyridine. The structure of Kineline is confirmed by Friedlander synthesis, which involves the condensation of orthoamino benzyl aldehyde with acetic aldehyde in the presence of alkali. Preparation of Kineline. Kineline occurs in coal tar and bone oil, from which it may be excreted with acids or it is made by synthetic methods. First is Scarpa synthesis, second is Friedlander synthesis, third is Fitzinger synthesis, fourth is Picht synthesis, fifth is miscellaneous synthesis. Scarpa synthesis. In this reaction, a mixture of aniline and glycerol is heated in the presence of sulfuric acid and a mild oxidizing agent, usually nitrobenzene or arsenic pentoxide. The reaction is exothermic and tends to become very violent. Ferrous sulfide and boric acid is generally added to makes the reaction less violent. Friedlander synthesis. This involves the condensation of orthoamino benzaldehyde with acetaldehyde in the presence of an alkali. Fitzinger synthesis. This is a modification of the Friedlander method. The required orthoamino benzaldehydes in the Friedlander synthesis are difficult to obtain and are often unstable. The difficult less been overcome in the Fitzinger synthesis, which instead use statin. Statin is in the presence of alkali is converted to isotonic acid with is considered with a ketone to afford Kineline. Miller synthesis. The organic reaction of aniline with alpha beta unsaturated carbonyl compound to form Cumuline. Physical properties of Kineline. Kineline is a colorless liquid. Boiling point is 237 degrees Celsius. It turns yellow on standing and has pyridine-like smell. Kineline is miscible with most organic solvents and dissolves in water to about 0.7% at room temperature. Chemical properties of Kineline. The most typical reaction for Kinelines are heteroatom reaction, electrophilic and nucleophilic substitution reaction, and last is oxidation and reduction reaction. Heteroatom reaction. The nitrogen in Kineline, which undergoes protonation, alkylation, acylation, etc. Kineline is a weaker base than pyridine. Second is electrophilic and nucleophilic substitution reaction. Electrophilic substitution reaction occur on the ring carbon atom, mainly on those of the more activated benzene moiety. Nucleophilic substitution of Kineline occurs in the electron deficient pyridine ring, as a rule in the position 2 or 4. Electrophilic substitution reaction occur in position 5th and 8th of Kineline. Treatment of Kineline with nitrating mixture results in 5 and 8 nitroquinolines. Sulfonation of Kineline produce different products depending on the reaction temperature. At 220 degrees Celsius, Kineline 8-sulfonic acid is formed predominantly. At 300 degrees Celsius, Kineline 6-sulfonic acid is the sole product. When heating to 300 degrees Celsius, Kineline 8-sulfonic acid is converted into Kineline 6-sulfonic acid, which is the thermodynamically favored sulfonation product. Nucleophilic substitution produced faster in Kineline than in pyridine. Nucleophilic substitution of Kineline occurs in the heterocyclic ring as a rule in the position 2nd. Oxidation and reduction reaction. The pyrimidine ring is hydrogenated prior to the benzene ring of Kineline. The product of reduction depends much upon the reaction condition. The alkaline permanganate solution causes oxidative cleavage of the benzene ring in Kineline to give quinolonic acid. The reaction of Kineline with peroxycarboxylic acid leads to its N-oxide. Basicity of Kineline. Kineline is a stronger base than isoquinoline is a stronger base than Kineline. The lone pair electron of an atom of isoquinoline are far from the benzene ring, thus get not involved with p electron of benzene. Bioactive Kineline and isoquinoline. Kineline is an antimaterial. Uses of Kineline as a high boiling basic solvent to yield pyridine 3-carboxylic acid in the manufacture of pharmaceuticals, dye and insecticide. Kineline is not found in nature, although a number of alkaloids contains this nucleus as well known, and many of them function as therapeutic agent. Cinchona alkaloid are isolated from the bark of cinchona tree and are Kineline's base. The structure of quinine can be represented as quinine has been a standard drug for the treatment of malaria for centuries. It has, however, been suppressed by a number of more potent synthetic drugs such as chloroquine. Many commercially available dyes also contains the Kineline nucleus. The cyanine dye used for improving the color sensitivity of photographic emulsion have been reviewed by Hammer. Thank you.